So in this tutorial, I'll be going over sets. A set is essentially a group of objects, which are elements in the set. Elements of a set are typically mathematical objects, such as symbols, shapes, and numbers. For example, in this set, the elements are 1, 2, 3, and 4. Sets can also have subsets in it, which are like smaller sets within a set containing elements from the original set. In the image below, subset B is part of set A. This is true because set A contains all the elements in subset B. You can write this as B subset to A like this. Like this. And this is true since A contains all the elements in subset B. A has the elements 1, 2, 3, and 4, while B has the elements 1 and 4. And since 1 and 4 are both inside of set A, that means set B is a subset of set A. So moving on, sets can also overlap, which is the intersection of sets, and it's written as A and B. And in the example below, set A contains 1, 2, 3, 4, and set B contains 1, 4, 5, 6. And 1 and 4 are the overlap since they both include it. So 1 and 4 is the intersection. Are there any questions? Okay, so
I think we understand.
two or more sets combined is known as the union of sets. It can be written as AUB, union B, and it represents all the elements of both sets. In the example below, just ignoring this image, set A has 2 and 3, and set B has 1, 4, 5, 6. So added together, it means that AUB union B is equal to 1, 2, 3, 4, 5, 6. Example, set A has 1, 2, 5, 6, 8, 9. And set B has 1, 2, 3, 5, 7, and 9. And since in this set there's some overlapping elements being 1, 2, and 5, you must subtract, and 9, you must subtract these elements from the final answer. So there's not going to be 1 2 times. It's just going to be 1 once. So A union B will be 1, 2, 3, 4, 5, 6, 7, 8, 9. In that example, we use the union formula of two sets, which is A union B is equal to A plus B minus A intersect B, which is like you use like a Venn diagram, and then you basically, it's like you have two circles over each other, and then you subtract the middle part because they're overlapping and you only want one layer of things. And the union formula of three sets is basically the same thing, but instead you have three Venn diagram circles, which means there's these intersections as well as all of the intersections together. So you still add all the circles together and then subtract the intersections. But since you have subtracted 3 times, you need to add the middle one back in, which is why you add the middle intersection. To calculate the number of subsets in a set, the formula is 2 to the power of n, and n represents the number of elements in the set. And in the example below, the set has the elements A and D, R, E, W, H, and it asks specifically for the even number of elements. So you could solve this by doing 2 to the power of 7 divided by 2, since every other number is even. So if you divide by 2, you'll only be left with the even numbers. And doing this, we can get 64. So basically how this formula works is that there is an empty set, which is like just a set with nothing in it, and then with each element, like A, you have the option of putting it in or not putting it in the subset, and you branch off each time with each letter, and that's why you do it to the power of 2. I mean, the base of the power is 2, so. And there's also something called a proper subset, because in a subset, you can also have a full set. Like the subset can have all the elements in the set, the original set. Like if the set was 1, 2, 3, 4, the subset could be also just be 1, 2, 3, 4. But that's technically not a proper subset since the elements in the set are equal. So to get rid of that, you just simply subtract 1 at the end. Like in this example, how many proper subsets are there for DORA? It's 2 to the power of 4. But you have to minus 1 because there's one improper set. So you'll get 15. Are there any questions?
I think we're good.
Okay. Okay, so the calculation of the number of elements is that in some cases, you need to calculate what elements are in a set, like if it gives you like a range and a requirement. So for example, if the set has 5 divided by 2 element, like 5 over 2, then the amount of elements in the set would be 2.5. But since you can't have a fraction of an element, you have to round it. And using the floor function, which is an x, it tells you that you have to round down. So you would just have 2 in that set instead of 2.5 or 3. Okay, so here's a practice question. So every member of a book club is taking drama or literacy, and 12 are taking both. If there are 23 taking literacy and 15 taking drama, how many members are in the club? I'll give you guys 3 minutes to solve this problem. Okay, so it's been about 3 minutes. So I'll show you how to solve this problem now. So basically in this problem, you can see that there's three givens, which is A intersect B, A and B. So we can just say literacy. Taking literacy is set A, which will be equal to 23. And people taking drama is set B, which can just be 15. And then the intersect will be A and B is equal to 12. And we can use the um, union formula of two sets, which is this. And like, I'm gonna write it up here, but you just have to plug the numbers in. It's 23 plus 15 minus 12, which is equal to 26. Are there any questions?
I think we understand.
Okay. So I have some other practice questions. You can see the answers, but like let me just okay, so there's this problem, which is there are 50 flowers, 27 of them have white petals, and 31 of them have green stems. And the question asks how many flowers have white petals and green stems. I'll give you 2 minutes to try this problem. Okay, so it's been about 2 minutes. Okay, so to solve this problem, first you have to identify that there's three givens, which is which you get A and union B, which is the 50 flowers. So AUB equals 50. And you also get set A, which can be the white petals, and set B, which can be the green stems. And then you can use the formula of two sets, which is this. And since you're not finding a union B and you're finding A intersect B instead, you can rearrange the formula into this, which basically you just bring the intersection to the front and then you bring the union to the back of the equation. So and then you can just plug in the numbers. And then you can just solve for it, which will give you 8. So the intersection is 8. So there are 8 flowers with white petals and green stems. Moving on to the next question. So this question reads, in a school of fish, there are 7 fish that have red fins and purple scales. 20 fish have red fins and 16 fish have purple scales. How many total fish are there? I'll give you 2 minutes to try this problem. Been about 2 minutes, so I'm gonna show you how to solve this problem. Basically, you can identify 3 givens in this problem as well. The fish with red fins is set A. The fish with purple scales is set B. And the intersection A and B is 7. Once again, we're going to use the formula of 2 sets, which is this. and it's kind of long, so I'm not going to write it out again. But you don't have to rearrange this time since you're finding A union B. So then you can just plug in the numbers. And you can get the final answer. So A union B is 29, which means there's are 29 total fish. This is another problem. I'll give you 2 minutes to try this. Oh yeah, are there any questions for the previous question?
Oh, I understand.
Okay, got it. It's been about 2 minutes, so I'll solve the problem now. So in this problem, you're given 4 givens. So you know since you're finding like something that's not in either of these groups, 50 is the universal set, which can be represented as U, but like then so we can have set A be the vegetables rich in vitamin C and set B, oh, oops, be the set of vegetables rich in vitamin D, and intercept B is 5, and can once again use the formula of 2 sets to first find how many total vegetables that are rich in vitamin C or vitamin D, which is this formula. So I'm just going to plug in the numbers. 15 plus 20 minus 5 is equal to 30. And then we subtract AUB from the total amount of vegetables or universal set, and which is equal to 20. So there are 20 vegetables that are not rich in vitamin C or vitamin D. Is there any questions?
We understand.
Okay, so moving on to the next question. So I'll give you 2 minutes to solve it. It's been 2 minutes, so I'm going to show you how to solve the problem. So you can identify 4 givens here. So you have set A, which is the people who can speak English, set B, which is the people who can speak French, and set C, which is the people who can speak Chinese, and the universal set, or A, U, B, U, C, is 100. So first, you need to find the intersection between English and French or something, or like English and Chinese. So you just basically you're using the formula of 2 sets, but for 3 things, because you can add Chinese in after, since it's only asking for at least how many people can speak all 3 languages. So you just do this and then you subtract 100. Which is 49. And then you can add 49 to set C and then subtract 100 again. To get the answer, which is 22. So there are 22 people who can speak all 3 languages, at least 22 people. Any questions?
No questions for this one.
Okay. Moving on to the next question. Yeah, I'll give you guys 3 minutes to do this one because it's a bit longer. Okay, so it's been about 3 minutes. And I'll show you guys how to solve this problem. So in this problem, you use the formula of 3 sets since you're given all the variables needed to use it. And the formula is this. It's a very long formula. And so I'm just going to plug all the numbers in. So we can just have the amount of people who have fish as set A, and the amount of people who have a dog as set B, amount of people who have a cat as set C. And then we can just subtract all the intersections as listed there, here. We'll add the A and A intersect B intersect C, which is 5. And then we can simplify it into this, which is equal to 74. So now we know that the amount of people that did pick an answer on this list is 74. We can find how many people who did not choose an answer on this list by subtracting it from the universal set, which is 100. So we can just do 100 minus 74, which is equal to 26. So now we know that there are 26 people who didn't choose an answer on this list. Are there any questions?
I have a question. Like,
The question.
what would happen if there was like 7 sets instead of 6? Like, what would you do?
7 sets.
Yeah.
I mean, I guess you would just have a really long formula.
Okay.
You would just have to add all of the sets together, subtract all of the first intersections, and then you would probably have to add, like, you would probably have to subtract all the intersections between 2 of the sets, and you would have to add back the intersections of 3 sets, but then you also have to subtract them, and it would overall just be a really long formula,
I
I
see.
think.
I understand.
Okay, are there any questions other than that?
No.
Okay. Well, that's all for this lesson. If you want to try more problems, you can go to this super cool website and try the problems on this website that are super cool.